So now you and your partner have finished measuring the distance your ball traveled and the time it took to go certain distances. So the question is, what was it that we were calculating? And the answer is, of course, speed, because speed is defined as the distance traveled divided by the time it took to travel that distance. So take a second, get that into your packet. And then we need to add in what are the units. So the units is just simply ask yourself, well, like, what did we measure? So we measured distance using the units of, how do I turn on my little pen? The units of meters, right? So meters, and the time that we used were seconds. So that color is absolutely awful. Apologies. Let me see if I can change it. There we go. Now you can actually see it. Okay, meters per second is how you say that. The per means divided by. So if speed is measured in meters per second, in this case, is it always measured in meters per second? No. Can you think of some other units of speed that are commonly used? So in your packet, write down a couple examples of other units that are used to measure speed. If you're having trouble getting started, think about your car and what units the car's speed is measured in, and see if it follows the rule of its distance divided by time. All right, so let's now look a little closer at what actually were we measuring, because the ball did a lot of different things, right? It started out quickly at the beginning, and then it slowed, and in some cases it stopped. So actually, the ball traveled a bunch of different speeds, right? So we need to even be more specific in our definition here. So let's start with instantaneous speeds. So if you could somehow take a snapshot of just a moment in time and figure out how fast the ball was going in that snapshot of a moment, that would be your instantaneous speed, right? In that instant, what was the speed? But if you think about it, that's actually really hard to measure. So more commonly, what gets measured is an average speed, because you can take a longer period of time and divide that into the distance that was traveled. So now we've got two different types of speed here. We've got instantaneous and average. So here are some definitions to add. So if you take the total distance traveled and divide it by the total time it took to travel that distance, that's your average speed. Whereas instantaneous, as we said, is the speed something is traveling at a particular point in time, which can be much more challenging to actually measure. All right, so here is a very silly example of instantaneous versus average speeds. So maybe some of you are familiar with the fable of the tortoise and the hare. And I am going to do my best to insert this video at this point so that you can watch it. It's just a couple minutes. And then we'll come back and answer some quick questions about
it. The Tortoise and the Hare. There was once a tortoise that slowly crawled through a forest. Boing, boing. A bouncing hare saw the tortoise and made fun of him.
Make way! Make way! I'm bouncing through! Hey, Slowpoke, didn't you hear me? Move out of the way!
The angered tortoise stopped walking and said,
Hey, let's race to the top of the mountain and see who gets there faster.
You think you can beat me? Fine, let's do it! Ready, set, go!
So Hare bounced away and Tortoise slowly crawled. Boing, boing, and away went Hare. While Slowpoke Tortoise crept and crawled with bullets of sweat dripping down.
Now where is Tortoise? Wow, he is so far behind. It'll take him forever to catch up. So, I think I'll take a nap.
While Hare slept, Tortoise never stopped walking. Balump, balump. Sure enough, Tortoise crawled past sleepy-head Hare, and he crawled to the top of the hill.
Hey, Hare! I beat you! Ha 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 ha!
Huh? What? What's going on?
Hare woke up and scurried up the hill. But it was too late. Tortoise was already resting under a tree at the top of the mountain.
No, this can't be. I lost to Slowpoke Tortoise.
All right, so now you've watched the video. In your packet, we've got 3 questions to answer here. And just for fun, I would like you to answer the questions by actually drawing an image of a tortoise or a hare, depending on what you think the answer is. So first question, which animal had the greatest average speed for the entire race? So on your packet, draw an image of the animal that you think had the greatest average speed for the entire race. Question 2. Which animal had the greatest instantaneous speed during the race? So was it the tortoise or was it the hare? Draw a little image. And last question, which animal had an instantaneous speed of 0 at some point during the race? So again, draw your little image. And pause till you're done and then come back and we will go over the answers real quick. All right. Let's see, greatest average speed is, of course, our tortoise, right? So the tortoise and the hare both travel the same distance. So that in the fraction of distance over time, that's the same, but the tortoise did it in a shorter total time. So if you divide that out, that is a greater average speed. So the tortoise had the greatest average speed. Whereas the instantaneous speed record definitely went to the hare, right? Because at some points in the race, the hare was traveling much faster than the tortoise ever did. And the hare also had an instantaneous speed of 0 during the race because the hare took a nap, at which point it wasn't making any progress over the distance, so that caused an instantaneous speed of 0 during those moments. All right, one last definition here, because velocity is a word that is commonly used to talk about speed, and we just need to understand that velocity and speed are not actually the same thing, and in physics, of course, it matters. So velocity, let's go ahead and add this to your packet, is a speed that has a direction associated with it. So as soon as you add a direction, then you're talking about velocity. So the example on the slide here is if you say we're driving north at 25 miles per hour, that is a velocity. If you just said we're driving 25 miles per hour, that is only a speed. So as soon as you add a direction, now you're talking about velocity.